In this tutorial, I will be explaining the self-driving simulator I have made. If you haven't watched it yet, I recommend you to go to the video in the screen and click on it. I will explain the project and also the algorithms I used. We will see also how the code works that is made in C#. The entire project is made in Unity, and all the cinematics that are behind it are also made with this tool. Okay, introduction. I will explain in this tutorial the fundamentals of the project, okay, how it works, and um, how the algorithms work also. I will also make a brief explanation of the simulator. Then I will show you in the next few tutorials the detailed explanation of each component used. So for example, the genetic algorithm, the neural networks, the camera, the car controller, and all the artificial intelligence stuff. I will also explain the main artificial intelligence algorithms that we use, the neural networks and the genetic algorithm that will be complemented, and also the car, the lasers that we can see here, how we bypass the distances, the controllers. Okay, so why I made this project? If you make this project, you will learn a lot of artificial intelligence and why is so useful. You will understand the neural networks because the neural networks are the more complex thing and abstract of the entire project that you can't see it but is working. I will only use the neural networks for the feed forward that I will explain later. I will not use the backpropagation, but I have another video explaining it if you want to see it. I will also explain the power of genetic algorithms and how they work, and join these two artificial intelligence tools to make cars driving. Um, and also, this is another factor, but as not as important, but it's pleasing to see this 3D simulator because it has, I think, good graphics and lighting. So if you want to do a good project with algorithms and also the 3D view, this is your tutorial, I think. Understanding the project. Okay, if you have seen my video, my preview video showing this project, you will have seen that at the first time we create a populations of cars. I have 50 cars in my project, but you can put whatever you want. Each car will have some special genes that this is why we use genetic algorithm. We'll use the the genes and the DNA to create different cars, but only using the fittest genes. Um, yeah, these genes will describe the behavior of each car. Each car will have its own genes, and each car will have also some inputs. The lasers measure the distances from all the objects that are around him, and these inputs will be given to the neural network. With these inputs and these genes, we will make a special algorithm that will execute it, and it will give us only one output that will be the rotation, and I also made it to give us the acceleration of the car. New generations of cars will inherit the best genes, okay? Because we will be iterating this population and this controller a lot of times. When all the cars dies, we'll make another generation with the best genes of the previous generation. I will use an special environment. Firstly, I will use for the engine the Unity 3D, the last version. I will use for the scripting of the entire project C Sharp, but you can also use Java, C++, or other languages, and use other engines like the GMonkey engine for Java, the Unreal Engine or Cocos engine for C++, or whatever engine you want. Uh, because I will explain the most important code of this project and how it works. I think that with these tutorials, you will be able to create your own simulation, and even I will be creating this with us, with you in Unity 3D. The Unity project. Okay, the Unity project will consist on 4 different sections that we will be explaining. The terrain that will be done in Unity, including the circuit, the meshes, and all the surrounding objects, and the lighting. Then we will have the car. The car will have the neural network and the DNA, the controller that will handle all the cars, the genetic algorithms, and all the updates. And finally, the camera that will be following cars or changing the point of view. The car. As you can see in the image, we have 4 cars, okay? Each car with its own neural networks, with its own inputs. Each car will have 8 inputs that you can modify this variable, and it will have an special genes that will make it sensible for the walls. Okay, each car will have different sensibility to the stimulus that we will be changing for the greatest sensibility. In the car script, we'll have a laser handler that will carry out uh, the the measure of the distances to the other objects. It will have as parameters the color, the max distance if it's not an object in front of it, the the angle of view. For example, here there is 120 degrees. Okay, you can do it, for example, like 180 degrees, whatever you want. And the final parameter will be the number of rays that I have said before. The laser script will be created through all the rays, the iteration of each ray. You will have the raycast that will measure the distance, and the light rendering that this will be only for the visibility that we can see here. And finally, we will have a function that will be the updater that will update the rotation and position of the lasers depending on the position of the cars. So we have here a fragment of the code. These are the variables that I have said before. The height is important because we can put the lasers a little bit upper from the cars. We'll here create the instance of each game object that will be a laser. We'll create as lasers as this variable, and then we will add a component and create it that will be the laser that I have explained. This laser will have the color, that is the visibility. The laser is always the visibility, okay? The distance of the laser for measuring the distance, and the position. Finally, we'll have a function that will get the distances. The component laser will have a method called getDistance that will get the proportion between the max distance of the laser and the heat collision to an object. Secondly, in the car class, we'll have the neural network. This is the most complex thing of the entire project because it's a bit abstract and it's difficult to understand it the first time. But I think that with this project you can do it. The neural network. So a neural network that we can see here, will have some inputs. Here we'll give the neural network the values of each ray of the distance that I have tell, and it will give the distance will be from 0 to 1, and if it's 1 it will be that is not detected a wall. Then we'll have the hidden layers that is like the neurons that will give a more intelligent view of each car. Then we will have the outputs that with the inputs and the weights will get an output. The outputs will be the rotation and acceleration from 0 to 1. So for example, the rotation, if it's between 0 and 0.5, will be rotating left, and from 0.5 to 1, rotating right. And depending on the value, it will be more rotating or less. The weights are the relations between the previous layer and the next layer of each pair of layers. This will store a value that will be a gene of the car. For example, here we will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 genes. Okay, but in our network it will be more. And the main cause we do the neural networks is because then we will apply the feed-forward function that from the inputs and the genes will have the outputs. For example, the S1 that is here will need to multiply the X1 with the weight, this weight, add this to X2 with this weight, and add finally this to this weight. Okay, that is not written, but the previous layer, all the neurons are connected to each neuron of the next layer, so there will be here another way. And finally, when we have this sum, we'll apply a sigmoid function that is here that will have the values for 0 to 1. So if the values are very high or very low, it will give, if they are very low, approximately to 0, and if they are very high, they will get to 1. And here it will be the max variation. But this will be done because we want only values from 0 to 1, from 0 to 1. So the general equation, because this is example, will be this. If we want to get the neuron value of a layer and in position 1 and 2, layer 1, we'll need to do the sum from all the previous layer size, it will be 3, and multiply each neuron of the previous layer, layer -1, with the weight connected to this the the value we want to get and the neuron that is here. So for example, this x1 with s1 will have this wave, so we will multiply this wave with x1. Here we'll have the initialization of the neural network. We will create a list of weights that will be the layers, and each layer will have a float that will have these values, okay? A matrix that will have the weight values. Then we will create the neurons that will be a list, layers, and another list that will be the positions. And we'll get the size of the layer. And with this, we will iterate and create all the values depending on the DNA that we want. So with the DNA, we'll create this structure, okay, assign to all the weights the values, and we will also fill all the arrays of the neurons. So I think that this is the most important part. And finally, we'll have the updating of the neural network. I put here you a code that with the inputs that I have explained before here, with the inputs and the weights, so the genes, we'll get the output. We'll iterate through all the layers, do this equation through each layer and each neuron also. We'll have here the sum. We'll sum the multiplying weights and the neuron. And finally, we will put the neuron next layer, the sigmoid function that I have explained here. That is this. So I have do the same that I have explained. So perfect. Now, the genetic algorithm. This is the second most important artificial intelligence algorithm. We'll add to its car a genetic. So each car will have its own genetic. Firstly, they will be random, but then we'll get the fittest cars, and we will exchange and swap the different genes randomly to create better cars. So I have here an example. These are the values that will be stored in the weights of the neural network. It will be floats, so it will be decimals. We'll make a selection for the best cars. In this case, you can do from the distance, the farther distance, the most time of survive of the car, or even you can do with the speed, the best speed. You will do the selection depending of this fitness that you can think, and we will get, for example, the best and the second genes of the car. So we'll have the best gene and the second best gene. You can do with more cars, but I will be doing it with 2. Then we will do the crossover, that we will change some random parts. Because with the last population, we will create 50 new genetic genes, because we will have another 50 cars, and each car will have another crossover and another mutation. The crossover will swap, I have said, the genes, and then we will apply the mutation. We will do randomly some random values, and then with this we'll have worse cars, but also better cars. That is what we want. So the genetic algorithm is a bit random, but it works fine for a self-driving like this project. And then with these new values of the childs, because these are the childs, will be assigned to the new cars. So these genes will be assigned to the next population, next generation, to the neural networks of the next cars. Here we have the mutation and the crossover. The crossover will get the DNA of two parents. Okay, with these parents, will iterate through all the genes and will make random because we want to swap the sections and create the new weights of the child with different sections of the parents. And then we will add this weights layer to the child, and finally we will return the DNA of the child. The mutation is another function. In this function, with the DNA, we will randomly from 0 to 1 in this case do the mutation with a mutation probability, because we don't want to be completely random, because the best cars are the best cars because they have reached the best distance. So we don't want to do much random because they are not the best, they are not perfect, but they aren't also very bad. And we will return then the new DNA, the mutated DNA. And finally, the car controller, that is the main part that will handle all these things that I explained, the car, the terrain, the collisions, the camera, will create a population, a random population. The simulation will work, okay? We will update each car, we'll get the inputs of the lasers, then we will update the network of each car with these inputs of each car, and we'll return the outputs car. That will be the move. When all the cars are destroyed, okay, because they have collided with a wall or something, we'll get the best cars of this generation, and we will create a new population. We'll iterate through all the new cars that we want to create, and we will, for each car, apply the crossover of the genetic algorithm of the two best cars, and then mutate it, and we'll have the new population. So this is the new population. If we want to apply the genetic algorithm, we'll create a new list of the cars, the population, the number of cars, and we'll get between the best winner and the second, we'll cross over the DNA, get the new DNA, and mutate it with a mutation probability. And we will instantiate the car and add this to the main list. And this is the most important part of the project that handles all the neural networks and artificial intelligence. And finally, we have the terrain. Okay, I won't explain this a lot because you can do it as ever as you want. But the main concept is that the terrain will have a collider, and it will track. It will have a track, a circuit that will be triggered. Okay, when something collides on it, it will execute a function that is collide. And you can do the scene as you want with the track, do your custom track. I haven't made it procedural, but I think it's better to do it because you don't lose time. And then you can do the lights, the 3D objects, choose your car, the camera, the minimap that I have here, and the text that you can want to do. And finally, the camera. That this camera, I think that is a bit is intelligent because it chooses the best car to follow, and is looking always to a car. It follow or unfollow. You have two different functions. You can also, if you don't want to follow the car that has selected the camera, you can press Control to switch between cars. You can also update the movement of on cars. And if this camera that I have implemented have an intelligent rotate depending on the best view of the car, depending on the mountains or the best view of the car. And in the next videos, we have finally uh, done the main tutorial, that with this you can know the basic concepts of this project. And in the next two videos, I will quickly make a quick explanation of the C# and the programming basics for Unity. Then I also will be making an animated explanation of neural networks. And I will be creating the project from zero with the scripts, components, and settings in the Unity 3D program. If you have liked the video, please subscribe and give a comment with new suggestions, because I will be happy to know uh, what I can do and new tutorials I will be able to do. So I hope you like it, and see you in the next video.